Hi guys, and welcome to this WACE Academy online lesson on trigonometric functions. This lesson will cover syllabus points 3.1.5 and 3.1.6, and we'll be looking at the derivatives of sine x and cos x and using them to solve a practical problem. Let's get started. You may already be familiar with the graphs of sine x and cos x, but if not, this is what they look like. Between 0 and 2 pi, sine x looks like this, and cos x looks like this. Now, we can get an intuition of what their derivatives might look like by looking at some important points on the graph. We know that the derivative tells us the gradient of the tangent line, so straight away we can see 2 points where the derivative of sine x must be 0, pi on 2 and 3 pi on 2. Also, the gradient of the tangent will be at its greatest negative value at pi, as we can see if we draw the tangent line here. Drawing the tangent line will also show us that it must be at its greatest positive value at 0 and 2 pi. Connecting the dots here gives us a very familiar shape, cos x. Performing the same process with cos x quickly gives us the reflection of sine x in the x-axis. Otherwise, it gives us negative sine x. So hopefully you now have an intuition for these two very important facts, that if f of x is sine x, f dash x is cos x, and that if f of x is cos x, f dash x is negative sine x. So suppose we're given a function for the displacement of a particle on a straight line. Now, in a future lesson, you'll learn that if we have such a function, its derivative gives us velocity, and the derivative of that gives us acceleration. Therefore, this question is asking us to take the derivative and evaluate it at a particular point. So suppose that if x is 5 sine of t, then we know that the derivative is 5 cos of t. Evaluating this at pi on 2 gives us that v equals 5 cos of pi on 2, which is 0, since cos of pi on 2 is 0. Finally, we want to find the rate of change of the velocity when t equals pi on 2. This just means that we take the derivative of our function for velocity. Using our derivative for cos x, we get that v dash equals negative 5 sine of t. Since sine of pi on 2 is 1, we have that the answer here is negative 5. Hopefully now you understand the derivatives of sine and cos and are happy using them in some ways. In this next video, we'll be learning some of the more detailed differentiation techniques that we can use to deal with different looking functions. See you next time.